engineer, I remember someone said civil engineers protect people from the environment, and then protect the environment from people. So we're superheroes. That's what they called us.
Got you.
And I was like, I'm trying to be a superhero. Hi, everyone. Welcome to the inaugural episode of Engineering Greatness, an original podcast series from the American Concrete Institute. And today, my name is Erin Stewartson. I am your host, and I'm a doctoral student at The Ohio State University researching sustainable concrete. And my co host, an amazing co host, you guys, this is the first episode ever. We have the best with us today. His name is Charles, but he's not just Charles. He's the ACI president for the year 2022 to 2023. Hello, Charles. How are you?
Thank you very much, Erin. Good to see you again.
It's
Um,
good to
as
see
Erin
you too.
indicated, I'm Charles Mai, and I'm head of engineering at Master Builders Solutions in Cleveland, Ohio. I've been with the company since, oh my goodness, do I want to say this? Let's say
Gotta say
since
it.
1987. So that's been, quite a while. And as Erin did mention, I'm also fortunate and really humbled to be the ACI president for 2022 to 2023. You know,
All right. So now that you know a little bit about him, you don't really know everything about him, right? But we're going to get straight into the questions. So, of course, today in 2022, a lot of young professionals are trying to navigate the industry regarding uncertainty. So, 2020, everyone wasn't really sure what they were going to be doing, if their job was essential enough. And so they had to pivot. Some people had to pivot, some people got to stay in their industry. But the first question I have for you, Charles, is can you give us a two-sentence overview of the journey from your bachelor's degree in civil engineering to your current position as the head of engineering at Master Builder Solutions?
oh my goodness. I don't know if it's a two sentence
You can do three sentences.
response. Um, well, pretty much I got my undergrad degree from, Ghana. And I had an uncle, who was a structural engineer, had his own structural engineering firm. And the thinking at the time was, okay, I would go work with him, basically, and eventually take over the, practice. But I wanted to make sure I had an advanced degree in structural engineering,
Mm.
before doing so. So that was the primary reason for coming to the US to do my graduate studies, um, basically. Now, I ended up getting my master's from the University of Kansas. And then from there, went to Purdue University and got my PhD. And after that, I got stuck. So I didn't go
Stuck.
back. Yes.
Oh, okay. I need to understand the stuck part. Why did you get stuck?
Well, it was a couple of reasons. Number one, you know, I left to go to grad school. My colleagues, were started working back in Ghana, right? So
Mm.
they were gaining work experience, and even though from an educational standpoint, I mean, I had my PhD. If I went back without work experience, I would be starting from the bottom, sort of,
Mm.
because I wasn't going to go into academia. So the overall thinking was, okay, let me get some work experience and then go back. But in the
Mm.
process of working, I pretty much fell in love with what I was doing, and it's been a great ride. I mean, yeah, it's been wonderful.
Wow. So from feeling stuck, then you finally had a, I would say, a love for what you did. That's a very big transition from being feeling stuck to then loving what you do. So when did you start working at Master Builders, or did you have other internships or positions before that?
I was a foreign student, and when you're a foreign student, you don't have that many opportunities for internships. At least back when I was in school, you know.
Mm-hmm.
So pretty much, and also because I was working on experimental research, I didn't really have time to do internships because I was working on my projects. Um, and basically, when I finished, I ended up applying, to different companies. I did not want to teach, even though I had a PhD. That was not
Really?
in the cards for me. I wanted to work in industry,
Mm-hmm.
and I was fortunate enough to, get the position as a research engineer with back then the company was called Master Builders Incorporated. You know,
Okay.
yeah. And I tell people it's taken us you know quite a while to go from being Master Builders Incorporated to go to Master Builders Solutions.
Mm.
Very interesting. Yeah.
I love that. Okay, so let's see. You were stuck, and you started loving what you did, and then when you finished your PhD, then you applied for a job, and then you got the job as a research engineer. But how did you go from being a research engineer to now being head of engineering? I feel like there's a lot of distance that we didn't cover there, Charles, and you need to explain to me, please. Young
Right. Yeah.
professionals want to know.
Yeah. Yeah, it was kind of interesting. Back when I started, Master Builder Solutions is a global supplier of specialty construction chemicals in the um, um, in the concrete market, basically. And even though my background was in structural engineering, keep in mind that was the initial thing to go into structural engineering. When I got the job here, I got into materials. You know,
Mm,
which is totally, totally different, So very different from being a structural engineer, but it essentially opened up a whole world of opportunities for me. So I basically, you know, went from being a research engineer to managing, the engineering group down in the lab, and then
mm,
eventually moving up to the external technical support group, which is engineering group up in the marketing department. So I do interface with the lab, but then I have more of an external focus now. And my main interaction is with, design engineers and design professionals and, contractors and so on. And that's what really makes it exciting because no 2 days are the same. Yeah,
ooh, okay. I feel like a lot of people say that in the industry. No 2 days are the same in the industry. You don't know what's gonna happen. Okay,
yeah,
so you felt stuck. You got your degree. You went to Master Builders. You started as a research engineer, and then you kept on going up the chain, basically learning how to, I guess, increase your responsibility and do well with the increased responsibility you gained or you were offered. Okay, so, young professionals, if you hear that, you cannot always start at the top. That was one of the first things Charles just said. It's okay to start at a entry level position and keep working your way up. That's how you gain experience. All right, so let's
right.
go back to my questions. I'm gonna look back to my questions real quick.
Sure, yeah, right, yeah.
Okay, let's see. Oh, well, I guess you already kind of answered this question. One of my questions was there an event or a set of events that changed the trajectory of your career? And if so, how did you navigate it? And you basically just gained a love for your position. So,
Exactly, yeah.
would you say that being flexible or being adaptable is a great skill in this industry?
Oh yeah, and not just in this industry, in any industry, you
Mm,
have to be flexible, you know. And again, I got into this position, as I indicated, because when I got out of school, I did not want to teach, even though I had a PhD. I was a
mm,
structural engineer. A lot of structural engineering firms that I applied to, basically liked me, but then didn't want to take a chance on me because I had a PhD. And they
oh,
felt having a PhD, my main interest was academia. And I'm going to be asking you a question about that
mm.
soon, Erin. So get ready for
Okay.
that. You know, so they felt my main interest would be in academia. And if they took the chance of hiring me after maybe a couple of years or something, I might decide to go back into academia. So
Mm,
they really didn't want to do that. And I was fortunate to get the job at Master Builders because they had just started the engineering research lab and they needed somebody with experimental research background, which I had acquired during my master's and PhD work. So I went from structural engineering to materials. Then I saw the opportunity right there. You know, you
mm,
talk to a lot of design engineers, what do they lack? They lack knowledge and materials. And
right.
here was a perfect situation where having the structural engineering background, I could basically couple that with the materials expertise that I gained and really be able to provide, you know, service to the design community, you know. Now, bottom line is it's highly unlikely that you're going to be working um, in the same field that you trained. You need to
Mm-hmm.
be flexible. You need to look at opportunities, and it's been wonderful, honestly. Being involved at Massabuilders gave me the opportunity to get involved with ACI very, very
Oh,
early in my career. You know,
okay.
because the company does truly um, engage in all these standards development organizations, not just ACI, ASTM, PCI, and all of those in the different groups. But I ended up getting involved in ACI a long time ago. And just like I've been reading about you, you need to be engaged, you need to have the passion, and essentially just seize on the moment and the opportunities that come your way. You know.
Yes.
So now that said, quick question for you.
My
You know,
turn.
yeah, oh yeah, definitely. Because I'm looking at your background and it's why on earth did you decide to go into civil engineering? I can tell you why I went to civil engineering.
Let's see. Why did I decide to go into civil engineering? That's a
Yeah,
great question.
yeah.
So, when I was a kid, um, I would say I didn't really know what engineers did. I didn't really know how they did things either. Not gonna lie, I didn't know how to spell the word for a very long time. But I was talking to my mom about disasters because both my parents are from Jamaica and
Okay,
they both lived through Hurricane. I can't remember the exact name of the hurricane, but both of their houses were completely destroyed. And I
I
was
got you.
like, that's not fair to you guys. And they were like,
Mm-hmm.
yeah, I mean, we built our own houses. We thought we had, had the best materials. We had the best, I guess, materials to build something that would be resilient. But when the storm actually did come, it did not stand. And so that got me thinking about how can I change the materials that people build with so that, because they have the knowledge on how to build, but how can I change the materials on which they build so that their structures can actually be resilient? And when I found out who did that kind of stuff, it was, well, first you had to understand how to build, and that was civil
Mm-hmm.
engineering. And then for me, I always wanted to look at material science engineering, but I took a chemistry class in undergrad and it scared me away. And it's crazy today because I'm in materials research. I'm still not a material science engineer, like taking all the classes about the
Mm-hmm.
exact atom that you're working with, but I'm using materials to help, I would say, aid the construction industry and
Mm-hmm.
working towards sustainability. So that's definitely how I decided I wanted to be a civil engineer. I remember someone said civil engineers protect people from the environment, and then protect the environment from people. So we're superheroes. That's what they called
I
us.
got you.
And I was like, I'm trying to be a superhero. So that's actually why I decided to join civil engineering. I didn't grow up with, I would say, with people in the construction industry in my family. I
Mm-hmm.
didn't grow up. I mean, everyone built their own houses, but it wasn't because we had our own businesses. It was just because that's something you did. That was a normal thing. And my mom was like, "So what? I built my own house. What are you trying to tell me?" I was like, I'm not gonna say anything. This is you, mom." But I'm learning a lot of cool stuff in this program, and I think that's why I went into the civil engineering side. But I definitely was looking for more materials applications that I found in grad school. Yeah.
Now, based on what you said, I think I now understand, why you have the focus on concrete. However, that said, you know, I'm reading your synopsis, and you are in environmental engineering, right?
Yes.
So,
Yeah.
how does concrete play into that?
Okay, so that's a great question because I didn't know either until maybe 2 years ago, when
Mm-hmm.
I first started my PhD program. So in civil engineering, I did not get a lot of the chemistry background that I think maybe other schools gave. We focused more on geotechnical engineering. So that was actually my undergraduate degree. So I learned a lot
Yeah.
about soils and I learned a lot about foundations and um, just anything with geotechnical. So I was excited about soils, foundations, disaster levees, all this stuff. And then I was in ACI as a club. And I joined ACI because they said this is the most, I would say, low committed club. They called it low committed, but that was a lie. Okay, we were out here making canoes at 3 a.m., pouring concrete. But the interesting thing was they were like, this is something that you can just learn about. Like you can join competitions, they can give you a prompt and you have to try to have your specimen meet the prompt basically. And for me that was like my first view at experimental research, and seeing and having an informal option for experimental research without having to do data and data analysis. We do data analysis, but it wasn't for like you weren't supposed to get published off this research. So if you messed up, or if you thought you messed up or you failed, you still have another chance to try again. And so when I started to see the sustainability aspects of concrete, I was saying, we're making all this concrete. Where is it going? Like, who is it affecting? Are there any communities that are affected by concrete plants? Are there any communities that are affected by cement? And then when I learned about like the CO2 emissions that are produced from
Hmm.
producing 1 kilogram of cement, I personally made it I wouldn't say my goal in life, but definitely like a side goal, to try to be able to make concrete more sustainable, because I think concrete is an amazing material. Concrete is an
Hmm.
amazing production that man has created, but I would love to see the sustainability of concrete increase, especially with research that can be done by students. And this is not something that like you have to have a PhD to do. Like, I was doing it in undergrad, but I think that doing the work in graduate school and looking at how the environmental engineers see chemical bonds, see ions, see alkalinity is very interesting to me. That's what actually made me switch over from my structural background, because I was supposed to be doing structures, but I
Okay.
realized I don't like designing as much as I love chemistry now. And so I switched over, and they were all saying, come to the dark side, come to the dark side. I was like, I don't know if I can. I have no chemistry background. And I did a lot of work on the back end to try to get myself acquainted with chemistry. And it's helped me understand a lot of the pozzolanic reactions, a lot of the
Right.
um, corrosion reactions dealing with concrete as well. So I think that's why I really went over to environmental engineering. Oh, and also my research right now focuses on carbon. And so
Okay.
a lot of carbon analyzation is what happens in environmental engineering. And so that's another reason why I really appreciate I would say, the look that environmental engineers have, how they first started the chemical and how they first started the atom, rather than looking at the damage that's affected by concrete and wondering how that happened. We start at the molecular level first. Yeah.
Got you. Okay. Now, sort of threw me off a little bit because when I was in school, right, talking about environmental engineering, you know what that was all about? It had to
Water.
do with water and
Poop.
wastewater, water and wastewater, So that's what I'm trying to,
Hmm.
get a handle for, is that your focus or it's not?
It is not my focus, no.
Okay. Okay.
I actually realized at Ohio State, they said that all the classes I have taken so far would
Yeah.
be a civil engineering material science focused major,
Even
but
though,
they just don't have one. So
it,
that's what I have been doing. I've been taking material science classes as well, but
okay.
I'm now taking enough classes to have an environmental engineering major. That's
Okay.
basically what.
So the environmental engineering is just in quotes.
You know.
Yes.
Yes, I would say that I'm an interdisciplinary engineer. That's what I would say. There you go.
Got it. Got it. Got it. Now you did you know mention a couple of things, so I want to just hop on that as well. You talked about canoe, you know, building
Yes.
canoes and everything. So I presume
Yes.
you were also very much involved with the American Society of Civil Engineers student chapter because that's
Yes,
where
I
the
was.
canoes get built, right?
Hmm. Oh yeah.
Okay. So tell us a little bit about that experience, because it was
Okay.
still dealing with concrete, yeah.
Yeah, that was so. I started with ASCE Concrete Canoe first before I joined ACI. And the way that this happened, there was actually I had a mentor at the point in time. I had a fellowship that was given to me by my university, and the mentor, she was the president of ACI and Concrete Canoe at the point in time, project manager. And so she was like, "Hey, I know you're civil, and you said you don't really like concrete or care about concrete." I told her that. I felt horrible now looking back. Okay, look at me now. But she was saying that, "Hey, would you like to just come and be a part of a community in civil engineering?" And I said, oh, sure. Because before I had come in not really knowing anybody, and I'd taken all my normal classes, but when I finished taking all my gen ed classes, all my friends were in other fields. So I was like, oh, I don't have any friends in civil engineering. So she's like, yeah, would you like to be part of our community? It wasn't necessarily like, oh, we're making a canoe. She was like, we're a community. And so I actually got on the admixtures team and deciding which admixtures to use, which I think is still crazy because now I'm working with admixtures in my
Mhm.
research. Um, and so that was one of the first places, again, where I got to learn about informal experimental research and also leadership. So I became head of the admixtures crew, and then I became a mix designer. And so we did, like, I would say 2 or 3 mixes a week. And then for our big pour, it was a big community aspect again, where we just
Mhm.
kept on pouring different concrete, or like creating the hall, making sure the hall was there, pouring the concrete, going in shifts. I don't know. It was just an amazing experience. I would say being a part of a project starting from the ground up, and
Mhm.
that's actually why I like construction too.
Yep.
And just being able to, I would say, fail and know why you failed and learn from it, and then also to find the solutions to make sure that failure doesn't happen again. Um, yeah, so I think that's one reason why I like concrete canoe. And also, we all did our homework together as well. So it was
Yep.
like we just learned together, we
Mhm.
failed together, learned together. That was a big part of engineering. Failure is one of the biggest parts that people can learn from, I think.
Great. Yeah.
If you're not used to rejection or failure, it's going to be hard to be an engineer. but
Yeah.
but you learn from the failure, and that's one of my favorite parts about engineering.
Yeah. No, Erin, this is great. I mean, and to me, it's extremely exciting, and I'll tell you why, because I don't think you know this. Um,
Really?
Master Builders Incorporated, was the sponsor, for quite a while of the
Oh,
National Concrete Canoe Competition, the real big one, you know.
what?
Yes.
That's crazy.
And personally, I was a member of the committee for National Concrete Canoe Competition, for
Mm-hmm.
quite a while until Master Builders stopped sponsoring the national
Mm-hmm.
competition. So I'm very, very familiar with concrete canoe, you know, and one of the things that was enjoyable about going to concrete canoe was, I mean, that was where you saw the leaders of tomorrow, and we did recruit from the concrete canoe competition, So I mean, mentioning that tells me a lot about you. You are a leader.
Thank you. Thank you. Oh, one last thing. It helped
Yeah.
me appreciate materials because all the rules changed every year about what we could use.
Well,
So
when
like
I
we
was in,
stopped using silica fume, everything was changing. So I was like, wow, materials really changes how you
e- e-
build. So that's
exactly, yeah, and it's a good thing. I mean, when I joined the committee, they never really changed the concrete materials as, I mean, the concrete portion
Mm.
of it. And I said, no, this cannot be. We can't have
It was
uh, we
you.
can't have civil engineers going out there thinking they could use concrete with water cement ratios of zero point 0.8 and zero point 0.9. So I think, one of the first year, we set the limit at zero point 0.5. And of course, that's when they really had to start using admixtures and everything. And then after that, we kept on, changing different things to throw them off,
Yes,
So
you threw us off.
researching, yeah, so researching and concrete materials and trying to figure out, what to do and all of that, became part of it. And, from my perspective, it was a great way to have, the students learn about materials, concrete
It
materials.
definitely
Yeah.
was. Yeah, I
Mhm.
wasn't learning about every single admixture in class all the
Mhm.
time,
Yeah.
or at least I wasn't learning and then practicing using it. Like when
Yeah.
you guys said that we couldn't paint our canoes anymore, we had to figure out how to use dye, not dye, but I think it was concrete powder. But then we realized it messed up our water cement ratio, so we were just going back and forth. When I tell you, you guys, I think that you guys did a great job. Looking back now, of course, but in the midst of it, I was like, why can't we use silica fume? Why
Yeah.
not? But I definitely appreciate that change. That's
Mhm.
yeah, that probably really shaped how I think about materials. Wow, that's crazy. This is full circle moment right here. Just want to let you
Yep.
know.
Connect with thousands of the concrete industry's brightest minds at the ACI Concrete Convention. Held each spring and fall, the ACI Concrete Convention is the world's gathering place for advancing concrete materials, design, construction, and repair, bringing together the world's most well-known leaders with professionals looking to learn.
Okay, let me
Mhm.
see. I'll go back to some questions about you because you're the president. So I'll ask some more
Yeah.
questions.
Yeah.
Okay, so one question I have here is, let's see. Oh, well, I guess we already talked about this. We talked about flexibility and adaptability, but is there another personality trait or strength that you think someone who wants to be successful in this industry would need and required?
Oh, great question. One of the things is, I mean, and this translates into everything else, is to be a good listener.
Okay.
Yeah. You have to be a good listener, you know, and as you move up, you're going to end up working in teams. It's highly unlikely you will end up in a place where, you're working by yourself, no matter what. You will end up working in teams, and you will attend team meetings and everything, and you've got to be a good listener. Listen to other viewpoints, synthesize them, you know, and then say what you have to say, you
Mm.
know. That is always, to me, it took me a while to learn that, by the way. You know,
Ooh.
it's, yeah, but it's one of the greatest advice that I can give to anyone, is, just be a good listener.
How do you practice being a good listener? Since this is something you had to learn, did you practice?
Um, it's just, yeah, I mean, it's just making a conscious decision, when you go to, meetings and everything, just to hear other viewpoints. You might have some very, very strong opinions, and you will want to make sure you actually impose your, views on other people, you know.
Mm-hmm.
But it's always a good idea, even if you're very, very right, it's always a good idea just to listen to other people and then basically infuse your stuff in there, you know, and disarm them, basically. It works, Yeah,
Disarm. Oh man.
yeah.
Those are great. Those are great reasons to
Mhm.
listen. So let's see. You said synthesize, make your wouldn't say argument, but make your position and then
Yeah,
state what you want to say. Okay.
exactly. Yeah,
I'll remember that.
yeah.
I'm
And
working on listening.
right, yeah. And it's something also that I do, uh, let's say when I write, papers or I put presentations together, one of the things is to make sure that, okay, by the time, let's say you sit through my presentation, you would have formed your own conclusions, which would be pretty much in line with my conclusions. Or by the time you read through a paper that I've written, you would arrive at the same type of, final summary and conclusions. Yeah. So it's something that I, put into, both of those, basically, yeah.
Okay, okay. Everyone hear that? You got to listen. Did you
Yeah.
hear it or did you listen to it? Okay. Let's see. Oh, okay. I think this is one of my favorite questions I wanted to ask. So, what was your most challenging project you ever undertook and how did it shape your view of success?
Oh, most challenging project.
Yeah.
Well, there've been several of them. I've been working for a long time, there've been several of them. Um, but I would say maybe um the biggest one will be, when we developed and introduced a corrosion inhibitor, you
Okay.
know. Yeah. Now, just to give you a little bit of background, for quite a while, there was just one corrosion inhibitor in the marketplace, and that was calcium nitrite. It's a calcium nitrite corrosion inhibitor. And there was a patent on it, which was still active. So, nobody could really, develop their own calcium nitrite corrosion inhibitor. Now, the patent has expired now. So pretty much every admixture company in the world, has a calcium nitrite corrosion inhibitor. So we did develop our own corrosion inhibitor, an organic based, product. And I was involved in the development and testing of it. And I also got involved with the introduction of the product into the marketplace. And that was one of the times when I really seriously started working with design professional, design engineers, you know,
Mm,
to introduce this technology. And of course, we had to deal with all the competitive, uh, how do I put it? The competitive blowback, from the other company that had a calcium nitrite inhibitor, you know,
okay.
and essentially I got involved in all the corrosion committees you can ever think of, ACI Committee 222, I was
Mhm.
secretary and became chair of the committee. I was involved in the TRB, committee on corrosion,
Mm,
ASTM committees on corrosion test method developments, I mean, you name it, I was involved in all of them, NACE, PCI, yeah.
mhm.
And that really, I guess, made a real big, difference, to me because it got me heavily entrenched, with all the standards development organizations and the trade associations. But then, more than anything, that was when, my whole passion for expediting technology acceptance and use
Mm,
developed. So
okay.
you can see how that ties into my platform message.
Yes. See, I love that because that's what I've heard from many other I would say, leaders. They started with one problem that they wanted to figure out, and then they had all these committees that they joined, and they had all these companies that they didn't realize were stakeholders in the answer to their solution. Wow, that's amazing. That's because that was
Yeah.
actually one of my other questions, like, because you're an inventor, okay? Engineers also
Oh yes,
invent things.
yes, yes.
That's awesome.
I do have my name on a patent.
Okay, we see you, Charles. We
It's
see
expired
you.
anyway. Now, okay, now so I've got a question to you. Now we've been talking about me and everything. Let's talk about your research focus.
All right.
Yeah,
My
and
research currently, right? Oh,
okay, yeah, your research focus, and then also what you plan on doing. Once you're done.
okay. These are great questions because they all changed maybe 2 years ago. So
Okay.
my research focus right now is looking at the adsorption properties and reactivity properties of fly ash, reclaimed fly ash, harvested fly ash, and then seeing how we can actually determine them before putting them in concrete. Because I think before it was just like, oh, this is bad fly ash because we saw that our LOI and our air internally admixture demand is high. That's it. But we want to be able to we want to be able to determine that first by looking at the chemical properties and looking at the phase components. Basically like different types of minerals in
Right.
the fly ash. That's what you want to look at. And we're hoping to get, I would say, correlations to air training admixture dosage right now. And this is all to hopefully, I'm working with other universities to hopefully try to change specification ASTM C618, which of course everyone's trying their hardest to change the specification and get it revised. So I'm just a part of a much bigger group of people who would love to see more um, marginal fly ash and unconventional, maybe ponded fly ash come to the industry and be able to perform better than just normal cement in concrete. And my final career path, wow, my ultimate goal and career path, I would love to be in spaces where I can advocate for communities who are in environmental justice communities, basically where they would face either harmful materials or like I guess face the negative health impacts of harmful materials, as well as looking at researching how to put those materials into concrete. And most of the material I'm looking at right now is just coal ash, and I didn't realize how much I enjoyed all the public policy aspects, the research aspects. I don't even know how to explain it. It just all happened so fast. And I think that's what I would like to do. So right now I'm looking towards having an internship on researching fly ash and researching, of course, reactivity and adsorption in order to change specifications, but then also looking at the public policy aspect of it, because there's a really big public policy aspect of how we
Now,
use fly ash in the
now,
industry.
now, let me get this straight. Do you want to be an activist?
This is a great question. That's a great question. I'm nervous because like right now, I mean, I went to World of Coal Ash last week,
Yeah.
and I just heard about some people's careers are, really bolstered by being an activist, but some people's careers can be
Mhm.
very, very, I would say, endangered by speaking out against, or not speaking out against, but speaking for certain communities who
Mhm.
are experiencing environmental justice issues. So I am really trying to figure out where I fit in, specifically with research, because I don't want to leave research. I would love for that to be something that I do full time, but I would also love to be able to advocate for communities I know that are affected by a material that I would like to like take out of their community, basically.
Yeah.
um but yeah, I'm nervous. I don't know. I'm not sure. I'm hoping that this internship will help me gain a little bit more understanding about what it all entails, because I had no idea about material science researchers. I had no idea about being a public activist and a researcher at the same time. So this is all coming after having my mind, I mean, being exposed to all these things in graduate school.
Okay. So then, okay, I'm still trying to figure out exactly what you want to do. So
That's a great
basically, are
question.
you going to go into academia? Since you're talking about research, you want to go into
Um,
academia, or do you want to work with like one of the research institutes?
I would like to work with one of the research institutes.
Okay.
Sadly, I have no desire right now to teach. And I talk to my advisor about this all the time because I love presenting. I love presenting my research, but
Yeah.
I don't know if I would love to actually be a
Mhm.
professor. But I love to, I would say, help people come to a good conclusion based off of all the trade-offs and critical trade-offs that can
Mhm.
surround a decision. So that's what I like to do. So
Okay.
no
So
academia, no.
no academia. Okay. So you basically want to be like me. You know. Now
You know, I
let
didn't
me tell you a
realize it.
little. Yeah. No. Here's a little bit of thing. I did teach for 3 years part time.
Did you like it?
Oh, I enjoyed it, but I was still doing my day job. It was a
Okay.
night class, so yeah, I was still doing my day job, but I ended up having to fill in for a colleague, and then uh, after 3 years, it was like, well, I had to just give it up.
He
But then
said
I
you
do a
gotta
lot of,
go.
but then I do a lot of presentations, all
Hmm.
over. I attend a lot of conferences, just like you've started doing and everything. So I do fulfill that part of me, the academia side of me through those, activities. Now, you did bring up something, and okay, you're talking about fly ash and working with all the out of spec fly ashes and the um, effect that it could have on entrainment of concrete, which is one of the big things. Okay, so here's my question to you: what if somebody gave you a product that
Hmm.
you could use to essentially make concrete freeze-thaw resistant, but it wasn't an iron trainer? How will that solve the problem that you're looking at? Because then, I mean, whether the fly ash is out of spec or not, it wouldn't have any effect on the freeze-thaw on air entrainment.
Yeah, that's a great question. I think first I would want to do tests to see if it works with all different fly ashes, because that's what I'm doing now with my current air and training admixtures. And then secondly, if we actually have enough data to prove that it works with all fly ashes we want it to work with, then we would have to present that to the people who, again, work with, I would say, which admixtures are allowed in certain mixes. And then if those people say yes, then maybe we can bring it up to a even higher, maybe a state DOT, maybe federal. I don't know. I'm still learning about all the layers to design, and then see if those people would accept the work that we're doing. But also maybe only start in like one state or maybe one department, because not every state needs this. Not every state needs I would say the product. But I would definitely say like
Erin,
definitely start doing some research first.
Erin, you don't know what you've gotten yourself into,
Oh no.
because I'm going to put you in touch with somebody who
Oh,
will give you a yes, somebody who's going to give you a technology to include in your evaluations.
okay.
And this is
Thanks.
using, um, microspheres.
Okay. I've been learning about those. So
Yeah, this is using microspheres. And in fact, I think if you go back, there was a paper that was written. I'll send you all this information in later on, you know, but it does not involve using entering in admixtures. You know, it's a packaged material. You add it to the concrete. It provides microspheres. These are hollow microspheres, and they
hmm.
pretty much provide freeze or resistance to concrete. So will then
Wow.
allow you to use off-spec fly ash.
That's
You
cool.
see, you
Okay.
just added on to your research.
And so guys, this is exactly why you got to have conversations like this, cuz I had no idea. Definitely you probably hear about this at the next ACI convention in
Yep.
Dallas. Are you going to be there, Charles? You going to be there?
I don't think I have a choice, right?
Okay, so I think we're running slightly low over time. So how can people I wouldn't say get in touch with you, but how can they learn from you? Because you have such a wealth of expertise. Do you have any videos? You taught before? Do you have any, I guess, places where people can reach you? Any favorite ACI committees people can come and say hi?
um, Well, I mean, I think over the next year, it's going to be tough to catch me on ACI, committee, basically.
Mm-hmm.
However, since you brought that up, one of the things as ACI president is, you have to, or you get to write the president's memo, and
Mm-hmm.
you actually write 11 of them,
Oh, okay.
yes, and those appear in Concrete International, right?
Mm-hmm.
So every month you get to read my president's memo. Now, the first one was published, this month in the May issue of Concrete International. Um, and of course, it talks about my signature you know, uh, you know, platform message, which is expediting technology acceptance. Now, the thing that you're going to find interesting is the next two, um, titled "The Quest for Low Carbon Concrete,"
Ooh.
and parts one and part two. I started writing. You're limited to about 750 words. I mean, that's what Stack tells me. I'm limited to 750 words. I started writing, and before I knew it, I was over 800 words. So I decided to go part one and part two. So you will find them very interesting. So I would say be on the lookout for the June and July issues of Concrete International. But pretty much every month, you know, through next, March, I will have a column, a
Okay.
memo in there. Yeah. Mhm.
Okay, guys, you heard it here. President's memo. You got to read it. June and July, right? June and July. They're
Well,
dropping
no,
June and
well,
July.
yeah, no, but every month. It's going to be every
Oh
month,
yes,
yeah. But
every month.
the June and July are the ones that focus on the low carbon concrete.
Oh, okay, okay, okay.
And then of course
So
I have a catchy one for August. I'll tell you advance title, uh, fiber in my dyed strikeout concrete.
guys, this president is too cool, and you guys have to get to meet him. But first, you got to read these president's memos because that's where he's going to be telling about his life, his passion. Okay,
Yeah.
so I
Mhm.
also know that you do have a couple videos on ACI University that you teach. There are a couple seminars. I looked them up. Not gonna
You
lie to
look
you.
them up, okay? All right,
Yes.
okay, yeah.
But if you ever
Yeah,
want to learn something about him, there too, they're free for you.
yeah.
So
Mhm.
let's see. Okay, if you this is the last question. I promise. Last
Yeah.
question. If you could go back to graduate student Charles,
Mhm.
what word advice would you give him? And would it be different from first industry job Charles?
Oh my goodness. I'll be honest with you. I wouldn't change anything.
Hmm.
And I'll explain to you why. I go back, and I look over my life and everything, and it's amazing. It's been like a building block.
Hmm.
So one thing feeds on the other, and even though I majored in structural engineering, got my PhD in structural engineering, did all of those nonlinear, you name it, all of those, took all of those classes and everything. You know, um, I ended up in materials, and it's been great. But then I interface currently with a lot of structural engineers.
Hmm.
So to me, nothing, and also being a person of faith, I can see the building blocks.
Yeah.
You know, yeah, I can see the building blocks of it. So um, it's no, I wouldn't, yeah, I wouldn't
Okay.
change anything. Yeah. Mhm.
Okay, so accept things as they come, roll
Yep.
with the punches, be a
Mhm.
good listener. I think I remember that one.
Yep.
And even if you're stuck in a job, that doesn't mean that you can't learn to love it and excel where you are. Okay.
Exactly.
Well, guys, you heard it here first. This is the President Charles, Prince Charles. And we just had an amazing podcast at our first inaugural episode of Engineering Greatness, an original podcast series from the American Concrete Institute. My name is Erin Stewartson, and your name is.
Charles and Erin, thank you so much. You did a great job. Wonderful job
Oh,
hosting
thank
it.
you. Thank
Yeah.
you. We're so excited to have you here. So we're signing off. Have a great day, everybody.
Thank you. Bye bye.